So today what we're going to do is more kinematic problems, and what's nice about it is all the ones today are going to have acceleration. Because of that, we have 5 equations that we've been using and will continue to use. So it's going to be this guy. So this is when we don't have delta x, and then it's going to be the other 3 equations that we just worked on. So if you don't have V final, you don't have time, and you don't have acceleration. So these, we don't have the value for acceleration. So all of these equations are when we have acceleration. Okay, now what we're going to work on specifically today is the acceleration due to free fall. Now we've already learned about that because we dropped the balls out the window and we were able to get a velocity versus time graph. And what's the slope of velocity versus time graph? In general, velocity versus time graph, what's the acceleration? Or sorry, what's the slope? You guys. I know, I'm not giving you the answer. The slope of a velocity versus time graph. We found that, so we were able to get the acceleration. Do you guys remember what the acceleration was?
9.7 or something.
Yeah, so depending on what you got, but it should have been around 9.81. And the reason why is because that's the acceleration due to gravity. Okay? Now, if I have an object accelerating due to gravity, what do I know about the motion of that object? Like, where is it located? Like, what makes something accelerate just because of gravity? You throw it, and what happens when you throw an object? What does it do? Yeah, it flies through the air. That's right. It flies in the air, right? If something's flying through the air, then it's going to accelerate only because of gravity, okay? Now, can something be moving up and have acceleration due to gravity?
Yeah.
Yes. If the motion is upward, what's the direction of acceleration? What's going to happen when it moves up? It's going to slow down, and it's going to come to a stop. And why does it slow down if it's moving upward? Because acceleration is directed downward. So the acceleration due to gravity is always downward. So when an object's being thrown up, it's going to slow down. It's going to come to a stop. After it comes to a stop, what is it going to do?
Come down.
It's going to start coming down. Now when it's coming down and the acceleration is down, what's going to happen to the object?
Accelerate.
It's going to accelerate and get faster. Does that make sense? Okay. So if I have a word problem and I'm starting from rest, what is one of my givens?
VI equals 0.
VI equals 0. If I'm coming to a stop, what's one of my givens?
VI equals 0.
The VF, yeah, V final equals 0, right? If I'm falling in the air, what is my new given?
Acceleration.
Acceleration equals 9.81. Now what we're going to do, you guys, is we're going to round that. So if I'm accelerating, right, due to the force of gravity, so the only thing, I'm flying through the air, I'm either flying up, I'm going down, if any of that is happening, I now have a new given similar to my velocities, right? We have to read the problem. I have this scenario. I now know that the acceleration due to gravity is going to be 10 meters per second squared. So we're going to round that 9.8 to 10 meters per second squared, okay? So let's put this into practice. So we have a cat that knocks a flower pot off of a ledge. The flower pot hits the ground 2.7 seconds later. How high above the ground is the ledge? So here's my flower pot initially. And what can you tell me about this flower pot here? When it's on the ledge, what do we know about it? It's at rest. So what information is that for my given? Good. V initial equals 0. Excellent job. All right. Then it's going to fall down here to the ground. So it's falling. Now what do I know?
Time is 2.7 seconds.
I know time. That was a given. Time is 2.7 seconds. But what else do I know? Acceleration equals what?
10 meters.
So acceleration is 10 meters per second squared. What direction am I going?
Negative.
I'm going in the negative direction, right? So acceleration is always a downward vector. Acceleration is always down. So I'm going to put negative 10 meters per second squared. What are we trying to find?
Count the X.
Kinda. All right. So we
Or I guess just height. in
we
this case.
want to find height, but height is related to delta x. So we're going to use delta x to help us find our height. Now, can someone else tell me what's delta x? Do you guys remember? It's what? A change in distance. It's change in displacement. So here's the thing, you guys. Here's my initial position, and here's my final. If I do final minus initial, what kind of number should I have? Final minus initial. So let's say the ledge is 30 meters high, right? What should my displacement be?
0.
0 minus
30.
30. What's 0 minus 30?
30.
Negative 30. My displacement is a negative number, right? But height is going to be the magnitude of it. Height is just the magnitude of displacement. So displacement is my final position minus my initial. Because my displacement is downward, and downward is a negative direction, my displacement should be a negative value. So I'm going to solve for displacement, but because I'm only going from the ledge to the ground, right, then the magnitude of my displacement will be height. Well, let's take a look at this for a second, okay? So height, and we're going to use delta x to help us find this. So, what variable do I not need to solve this problem right now? V final. So we're going to use this equation here. So I have delta x equals V initial t plus 1/2 AT squared. So delta x equals 0 meters per second times time. What's going to happen to this part?
It's gonna be
0.
0.
And then plus 1/2 negative 10 meters per second squared times 2.7 seconds quantity squared. So you plug this into your calculator, you guys, and for our delta x, we're going to get negative 36.45. What are the units? What are the units for displacement? Meters. Okay, so the units for displacement are in meters. The question is asking for the height of the ledge. If my displacement from the ledge to the ground was down 36.45 meters, what is my height? 36.45 meters. Okay, so do you guys see how displacement is helping us to figure out the height? So the height is just how far from the ground to the top of the ledge that this flower pot was. Okay, so let's take a look at the next one here. We have a